Hey, everybody! This is Paul Grossman, the Dark Arts Wizard, and I want to welcome everyone here so much to the Zapple Tech Automation Meetup. It is always great to see you guys over here, and I'm really appreciate you guys to show up. This in case if you haven't figured it out yet, this is the fourth time I've been out over here, so I hope you appreciate seeing my face. I have hosted this three times in the last 4 months, and I was also a guest on last month's session. And this is really a fantastic forum where you get to learn a whole ton of new stuff by some of the most brilliant people that we've got out in the industry today. We've got two fantastic speakers for you. We got Jonathan Wright. You can catch him on his QA Lead podcast. But coming up first, we got Baz Distreka. I'm going to try that again. Baz Dijkstra, because I got it right the first time, but I was practicing, and it just I figured I'd try a second time on that just to mess it up, because that's what I do. A little bit about Baz is going to talk to us a little bit about contract testing, and then we'll hear a little bit about digital twin testing. These are two fantastic topics for me. Because I do know a lot about test automation, been doing it for 20 years, but these are two areas that are actually outside my wheelhouse. So today, I'm going to be learning something. You're going to be learning something. Everybody's going to be learning something. This is going to be just fantastic. Um, just see. Just a quick. If you don't know me, I'm known as the Dark Arts Wizard up on Twitter. I have a YouTube channel. You can go to YouTube/ Paul Grossman, the Dark Arts Wizard. Yes, custom URL. I got enough followers that I can do that. Um, and we have, like I said, we've got Oz over here waiting in the wings. And he does a lot of stuff. He talks a lot about different stuff. He talks about spec flow, cucumber, and I'm gonna mention behave. I'm not sure if he actually talks about behave, but I wanted to bring up spec flow because there is something interesting that new STATs in the field should know about. And basically, when they ask you, it's like, well, what do you work with? If you say, oh, I work in cucumber, I work in behave, or I work in SpecFlow, it actually means you're saying something else. It means I program in a certain language. So if you're working in Cucumber, you're basically saying, hey, I'm a Java developer. If you're working in SpecFlow, you're saying, hey, I mostly work in C# or .NET. And if you're saying, hey, I work in Behave, I'm working in Python. But it's all basically BDD, behavior-driven development testing. So it's really cool. Um, and we've got, like I said, we've got Boz just waiting in the wings to kind of give us a presentation on contact testing on his session. I'm looking forward to it. This guy's been around for quite a few years. If you've been in automation at all, you know Boz by his name. He's been on a lot of different podcasts and presentations. You can Google them up on YouTube and get a lot of good information from. I'm really looking forward to this presentation from him on test automation. Because I'll tell you what, I have been I'm just crazy about automation. I love doing it. I've been doing it for 20 years. And I love joining these sessions and hearing more about what we can do. It's like magic over here. So, everybody, what I'm going to do is basically bring Boz up on stage and let him take over on this. Let's see if there's Boz. I can see him out there. Hello, sir. How are you doing today?
Hey, Paul, can you just quickly confirm that you can hear me fine?
Yes, there's a little delay between what you're saying and what you're talking, but I can hear your mic. So that I think that's going to be just fine. I'm looking forward to
Awesome.
this. So yeah. So with that, I'm going to let you take it away for the next hour, and we'll have also one other thing. Everybody, there's Q&A. If you take a look on our restream over here on the far right hand side, there are messages that you can ask us and play Stump the Automation Engineer. Always a lot of fun game to play. And with that, Baz, take it away.
Thank you so much for that introduction, Paul. You almost took the 5 minutes that you promised me, so well done on that. And also well done on pronouncing my last name sort of kind of correctly. So Yeah, I know it's quite a hard last name to pronounce for people not actually Dutch like I am. So, but well done. Props to you. Um, and thank you for having me. As you said, as Paul said, I'm going in over the next hour or so, maybe a little bit less. I don't know. I'm going to talk a little bit about contract testing. We're going to see consumer driven contract testing. I'll talk a little bit about bidirectional contract testing. So, but contract testing in general. And for me, contract testing. Paul, can you quickly just confirm for everybody that you can also see my screen, the screen that I'm sharing?
Are all individual components and services able to communicate with one another? We can see that you are 5x5.
Awesome. That is exactly what I wanted you to see. Perfect. Thank you very much. This is basically the question that is so important in modern distributed microservices based software systems. So we have where we used to have these monolithic systems, we now have systems that are composed out of dozens, if not 100 different components, services, developed in different teams, different departments, maybe even different, totally different organizations. And you can test all of those individual components till you're blue in the face. But that doesn't mean that they'll all work very well when you stick them all together. You try to reproduce or try to support some kind of end user flow. So this is a bit. So the more distributed your system is, the bigger the problem is of answering these questions. All those individual components and services developed in different teams, organizations, are they really able to communicate with one another? So traditionally, and I've definitely been here, the way we try to tackle this, and the way we still try to tackle this, is in a very, very synchronous way, and trying to test everything at once. So the traditional way of doing large-scale integration and end-to-end testing is try to stick everything together, try to collect all those individual pieces, all those individual components, making sure that they're in some kind of testing environment at some point in time, all with the right data in the right state available, exerting the right behavior, and then trying to run some kind of coordinated integration end-to-end tests. And now the more distributed your system becomes, the more components you need to deal with, the harder this becomes. Because all of these components will typically have their own development delivery cycle, which means some components might not be ready at that exact moment that you want to do your integration end-to-end testing. It might be quite hard to set up the right state, the right data in it. It might be really hard to trigger some the specific kind of behavior that you want to use for your integration end-to-end testing. I've seen people basically doing this as a full-time job, making sure that test environments are ready to do this large-scale integration and end-to-end testing. But it's hard, and often it doesn't. It's quite painful as well, and doesn't really work. So, isn't there a better way? Well, this is the exact problem, the exact challenge that an approach like contract testing tries to tackle. And contract-based integration end-to-end testing is different from this traditional approach basically in two ways. First of all, instead of focusing on the integration of everything at once, so sticking this component A, B, C, and D all in the same environment and try to test all of these as a single entity, contract-based testing focuses on the integration of individual consumers and providers, or consumers and producers, or clients and so whatever you want to call it. So instead of checking if A, B, C, and D can all communicate with one another, you check, well, is able to communicate with B? Is B able to communicate with C? Is B able to communicate with D? So it breaks down that puzzle of large scale integration testing into smaller, more manageable pieces. Um, and the second way in which contract testing tries to address the challenges of the traditional approach of integration end-to-end testing is that it's an asynchronous process. So traditional integration end-to-end testing is synchronous, meaning all of those different components have to be in some kind of test environment at some specific point in time. And again, that's hard. And the more distributed your system and your development is, the harder that becomes, because people need to talk to another and say, well, are you ready? Am I ready? Can we stick those in? And well, it's painful. It's just painful. With contract-based integration end-to-end testing, that's an asynchronous process. So, which means that first I think back. So we have an integration, and an integration is a combination of a consumer and a provider, and both have to do that due diligence. They're part of the contract testing process, but those two parts, and so they don't necessarily have to do that at the same point in time. The consumer can do their part of the contract testing process as part of their own development and delivery lifecycle, and so can the provider. But that doesn't have to be the exact same point in time, which means it's an asynchronous process, which makes it much, much, much easier to manage, because you don't have to wait. You don't have to necessarily wait on other components to become available again. You can just do your part of the contract testing process as part of your development, your build, and your delivery lifecycle. The way it works typically, and I'm now going to dive deeper into what's arguably the most popular approach to contract testing right now, which is consumer-driven contract testing. So there are currently basically three different ways of doing contract testing. It's consumer-driven contract testing, which I'll show you, which we'll see in a minute. It's provider-driven contract testing, and it's bidirectional contract testing. And I'm also going to talk a little bit about bidirectional contract testing and its benefits later on in this talk. I'm not really going to address provider-driven contract testing, because a provider-driven contract testing is basically a provider saying, well, this is my contract, this is the way it works, this is the specification of my behavior, and all the parties that are consuming this API, well, they just have to deal with it. So it's much more like, this is what I do, you live with it. With consumer-driven contract testing, and also with that to slightly lesser extent with bidirectional contract testing, there's much more of a dialogue of, well, this is what I do, this is what you do, let's see if we can work together kind of discussion. But let's look at consumer-driven contract testing first. So the typical way this works is there's a contract. And that contract is the single source of truth, really. And because it's consumer-driven contract testing, it's the consumer who is responsible for generating the contract. So it's the consumer that lays out the rules of the game, really. And the way this works typically is a consumer writes tests. And as part of those tests, it specifies the expectations. And we'll see all of this in code and how it exactly works. So don't worry. The consumer writes down their expectations about the behavior of a provider, the tooling, and we'll see Pact as the tooling in a live demo in a moment, generates a contract that contains all of those expectations that the consumer has. From that contract, the tooling, i.e. Pact, generates a mock provider which that behaves exactly according to the expectations, which the consumer can then use to test its own implementation. But more importantly, that contract can then be distributed, passed on to a provider. And the provider then has the task, the responsibility of um, proving, of showing, demonstrating is the word I was looking for, demonstrating that its behavior matches the expectations of the consumer. And please keep in mind, a contract is an agreement between a single consumer and a single provider, which means that if there's a provider service that's being consumed by 4 different consumers, and all of these parties do consumer driven contract testing, the provider has to make sure, has to demonstrate it can live up to the expectations of all 4 consumers. It has to show and demonstrate that it meets the expectations in 4 different contracts. And yes, there can be uh, mismatches, there can be conflicts of interest. Um, and the funny thing, that's exactly that's something that you won't find out with a lot of traditional integration testing. It's not something that you can typically figure out just by testing the provider or just by testing the consumer. But it's a type of bug defect that typically only shows when you do this kind of contract testing. Um, so a little bit more about these expectations. So again, we have a consumer, we have a provider. This is the flow. No, the different sheet. I was expecting different sheet here. Don't worry. These expectations. Let's talk about these expectations for a bit. They are typically in the form of a consumer saying, well, if I do this, if I send this kind of request, and the provider is in this kind of state, then I expect the response to look like this. As an example, as you'll see in the code example that I'm going to show you, has a single provider that takes care of address data. This is all within the context of a web shop. And that address data, that address provider service, is consumed by 2 different consumers. A customer component, a customer service, which maintains and distributes data about customers. Customers have addresses, typically billing addresses, for example. And if you want to have get all the data related to a customer, you also want its address data. So that customer component, that customer service, consumes the address data to retrieve and present the data that's associated with a specific customer, for example. And we have another consumer, which is the order consumer, which manages data around orders in a web shop. And an order has an address as well, be it a delivery address, for example. So both of these, there are 2 consumers and 1 provider, and both consumers rely on the behavior of that provider. The way the typical consumer-driven contract testing flow workflow with tools like Pact works is we have a consumer, we have a provider. Let me quickly, no, there we go. We have a provider and we have a broker. And that broker, that Pact broker, acts as a kind of central source of the central registry, central library for all the contracts that live within a specific context. Plus, it stores contract verification results, meaning that it's for the consumer-driven contract testing flow, it's the consumer who uploads their contract, generates and publishes that contract as a first step in the flow. The second step in, again, a traditional consumer-driven contract testing flow is the provider downloading the contract and verifying the compliance, meaning demonstrating whether its current implementation is able to meet all of the expectations in that contract or in the contracts. As a third step, it publishes the verification results. And the final step is that both the consumer and the provider can then query the broker, which again has all the contracts and all the contract verification results, to see, well, now A, has everybody uploaded their contracts and the verification results? And B, are there any known integration issues? Or basically, to rephrase it, is it safe to deploy? Can I deploy? That's literally the name of the tool in the Pact ecosystem that you can use to do this, to query the Pact broker to see, well, with the current state of our contract testing, are there any potential integration issues that might break something in production? Let's have a look at how that works in practice. So here's is this font size big enough, Paul, or do you want me to zoom in a little to increase the font size a little in my editor? I'm going to interpret your quiet as this is okay. Let's start at the consumer side. For now, in the current state of the code, it doesn't really matter if I'm starting with the customer or customer consumer or with the consumer, because the current state of the code, they both have a set of expectations, and those set of expectations are exactly the same. So let's have a look at the customer consumer test code. In this test class, I'm basically two things here. As I said, I'm specifying the expectations that the customer has about the behavior of the provider in certain situations. So again, keep in mind this customer, both this customer consumer and the order consumer communicate and rely on the address provider. In this example, I've specified expectations for two different paths.
Hey, Baz. I'm sorry to interrupt. Yes, I was backstage for a second here. I was going to say, yeah, maybe if you can zoom it in a little bit better, a little bit more, it'll probably be better for us.
No worries at all. Let me quickly increase the font size a little. There we go. So I'm doing two things here. A, specifying the expectations that the consumers have about it, and then running tests that actually generate segments of the contract, and write the expectations to the contract, and also test the implementation of the consumer itself. So assuming that the provider behaves as expected, am I able to successfully process the responses? I've specified two paths here. So for HTTP gets, so retrieving address data, and for HTTP deletes, so deleting address data. I've not really bothered with coming up with examples, for example, for HTTP posts, for creating new data, but the principle is really the same. So for the get, so for retrieving address data, I have three different situations. I have the situations where I specify, and so I retrieve address data using an ID, and that ID is formatted as a UUID. So an address is uniquely identified by its UUID. And then three things can happen. The address ID is valid, and there's address data associated with that address ID in the provider, which should yield an HTTP 200 as the response code, plus data in a shape that the customer can understand and process. The second situation is, well, the address ID is valid, but there's no data, which means I expect to receive an HTTP 404, not found. And the third one is, what if that address ID is incorrectly formatted? So the customer can't guarantee that the address ID that's going to be sent is actually a valid UUID. So it wants to know that in case the provider receives an incorrectly formatted address ID, it should respond with an HTTP 400 bad request, basically. So for the 404 and the 400 situations, that's the HTTP status code is really the only expectation that's written out. So for the GET, if the request looks like this, I expect the response to have a status 404 and a 400 for these two situations. The situation where I actually expect data, so the HTTP 200 situation, the OK situation, I have some additional expectations because I have some expectations as a consumer about the shape of the response, meaning what does the response data look like? I don't have expectations about the actual values because that's testing the implementation of the provider, which I expect the provider development team should do. The provider developers or testers, automation engineers on their end don't really care who does it as long as they do it. But what I do expect is retrieving data in a shape, in a form that I can process. And that's where these expectations come in. So basically what this says, this is packed in Java, which allows me to specify using some nifty utility methods, what does the shape of the response data look like? So basically what it says here, I expect a field address type that should be a string. I expect the field street in there that should also be a string. I expect the field number that should be an integer, and so on and so on. This is a little bit of a special one. This is a utility method that generates a slightly stricter expectation. Basically, this says, well, I expect a field ID in there, and that should be not just any string, it should be a UUID. And basically that comes down to, well, it should be a string, but not just any string, but a string that matches a specific regular expression, namely that of a UUID. That regular expression that you can use to determine whether or not a string is a valid UUID. That is all those expectations during test execution are written to the contract. So let's just do that, run the test on the consumer side first. It is a little slow at the moment, but I can guarantee you it is running the tests at the moment. Or rather, it's compiling at the moment and it should start running the tests any moment. There we go. And when I run the tests, again, two things happen. A, I'm generating a contract, which can then be uploaded to the broker, so the provider can download it and use it to verify its compliance against the expectations in those contracts. And B, from that same contract, a mock provider is generated, which can then be used to test the implementation of the consumer itself. And both those things happen when I run these tests. So it tests the implementation of the customer consumer, and it also generates the contract. Which, no, I don't want to do that. Which ends up here. So this is the contract, and it's the contract between the customer consumer and the address provider, and it contains the expectations about what the response of the provider should look like in certain situations. So for example, in the situations where I do an HTTP GET and the address ID matches an existing address, this is an example response. And if I look at the matching rules, I see that, well, for example, for the address type, the actual value that is returned by the provider should match the type of this example. And the same for the city, the country, the number, the state, the street, the zip code. And again, that ID, which had this UUID, which we generated using this UUID method, says, well, it doesn't just have to match on the type. The actual value has to match this regular expression. And so we know that the value for the ID shouldn't be just any string value. It should be a valid UUID. I'm going to do the same for the order consumer, because that needs a contract too, that I want that contract as well. And again, in the current situation, the expectations that the order, so the other consumer that relies on the same address provider has, are exactly the same. I'm not going to show that to you yet, just have to believe me for now. The expectations that the order consumer has are exactly the same. So I shouldn't, as of now, I shouldn't expect any problems here. So this takes a while. Let me take the time to quickly introduce to you the pack broker. Packed Flow is a pack broker. It's a cloud-based pack broker. You can also there's also an open source version. So this is again a disclaimer. This is a paid product with a free plan. There's also an open source pack broker which you can host anywhere. It's a Docker image that the people behind Pact have made available. I'm using this one just for simplicity, really. But everything I'm showing you right now can be done with the open source Docker-based pack broker as well. I'm quickly going to go back to the customer consumer, because what I'm going to say now, again, we've run the test, generated the contracts. I'm now going to say, well, please publish that contract to the broker. And I'm going to do the same for the order consumer. So before I refresh, there is nothing here. It's a completely empty environment. Yep, that's done. And if I refresh Packflow now, you see that it now has two integrations, so two known contracts, one between the order consumer and the address provider, and the other between the customer consumer and the address provider. We can even zoom in and see, well, what interactions, so what specific situations are specified in that contract. So again, we have 3 situations for the customer get and 2 for the delete. But more importantly, as of now, those contracts are unverified, meaning the consumers have uploaded the contracts, have uploaded their specifications, but at the moment, it's still unknown whether the provider, in this case, the address provider, can meet all the expectations that are written down in this contract. So let's go over to the address provider side. Here they are conveniently in the same code base, which obviously will never happen in real life, but it doesn't really matter because we have the broker to manage and distribute our contracts. But here, I decide that literally pulls all contracts, and then for all the states, for all the situations, generates a mock consumer from the intent in the contracts, invokes the actual provider, and then checks if the responses returned by the actual provider match the expectations in the contract. So if I run pack.verifier.log. So by default, if I run the tests, it doesn't automatically upload the results, but I like to live a little bit dangerously, so I'm going to upload them right away. This runs my tests on the provider side, which again pulls the contracts from the broker, runs them against the actual implementation of the provider, checks whether the responses returned by the provider meet the expectations in the contracts, and then uploads those verification results back to the broker. So we are going to have to wait a little bit for the address provider to do their magic. Build success. Hooray. Let's have a look at the feedback in Flow now. And indeed, for both integrations, it says, well, we have a success. So, which means that there's a contract which was published 4 minutes ago and just verified, and all of the interactions have been checked success. So the current implementation of the provider is able to meet all of the expectations for both the consumers, meaning everything is fine in integration testing land, and it's safe for the customer consumer, the order consumer, and the address provider to deploy the latest version into production. If we change that a little, so for example, let's just do a very quick change. In case of an HTTP delete, for where the address ID is correctly formatted, I am no longer going to expect a 204, which is sort of kind of a de facto response for a successful delete. It's no content, basically. Let's say, well, no, the customer consumer in this situation now expects an HTTP status code of 200. What I then need to do is run the tests again, because I want to know that this doesn't break my consumer implementation, and I want this new expectation. So the fact that the customer consumer, in the case of a successful HTTP delete, expects a response status code of HTTP 200 instead of 204, I want that written to the contract, because that's new info, that's a new expectation that the customer consumer has about the behavior of the address provider. And the only way the address provider can be informed, can know about those updated specifications is, well, it needs a new contract. It needs an updated contract. So that's what it's going to do now. It's running the tests again. And this typically is a little bit, I think my machine is a little bit slow today, but that gives me some time to fill the time and to explain to you what's actually happening. And if I now publish that new contract, there we go, and refresh this, the pack broker will see, well, there's a new version of the contract, which is as of yet unverified. So here nothing has changed. I've really only changed the expectations for the customer consumer, which yielded a new contract, which is as of now unverified. And if we go back to the address provider, let's see, is this in my history still? Of course it is. To run the tests on the address provider side again. So it downloads the updated contract. It sees, well, there's a new contract. I need to, there's a new set of expectations that I need to meet. So it's pulling in that new contract. It's going to try and test whether can I still meet all of the expectations in all of the contracts. And I assume you sort of kind of know where this is going, because no, the current implementation of the address provider is not able to meet these expectations. It has failed now. So this one is still a success. So the current implementation of the address provider is able to meet all of the expectations that the order consumer has. However, there's an expectation that the customer consumer has expressed in their latest version of the contract that the address provider is no longer able to meet. And that's this one. So in the request to delete an address, well, it has status code, but so the contract specified an expectation of, well, in this situation, I expect a status code 200, but it was a 204. So the what the address provider actually returns is an HTTP status code 204. I could change the implementation of the address provider to return an HTTP 200 instead of a 204 and run the test again, but then it would break the expectations of the order consumer, because that one still expects an HTTP 204. And this is what I mean when I talked earlier about conflicts of interest. So the customer consumer has its set of expectations. The order consumer has its set of expectations. The address provider has its assumptions about how it should work. But whether or not all of these expectations match, you can really only find out when you do integration testing. And again, the order consumer, the customer consumer, the address provider, these three components, these three services might be developed in different teams, in different departments, in different organizations even. And that means that you really need some form, some structured way of making sure that you, preferably in an automatic way, in an automated manner, check whether the expectations that parties have about the behavior of other components, if they're actually true, if they're actually if they are realistic, if there are no conflicts of interest. And that's exactly what contract testing is trying to do. And that's exactly the way in which contract testing tries to address that question that I showed you on the first slide. Are all of these components at all times in a distributed system able to communicate with one another? That's the whole premise of contract testing, really. Now, I showed you an example in Java. The nice thing about Pact is that it's available for many different languages, including Python, C#, JavaScript, PHP, Go, and a couple of others as well, Ruby, which also means it's quite useful. So if your consumer is written in Java, but your provider is written in C# or in Go, for example, that's fine, because these contracts are basically JSON files. So they can be exchanged between a consumer in one language and a provider in another language, which is quite nice and makes Pact a really versatile tool, because with these distributed microservices-based systems, you don't always know what the technology stack is that the other party is using, and you don't want to enforce that, maybe. Or maybe you would, but you're not always in the position to enforce that. And Pact does this really in a programming language and technology stack independent way, which I think is quite nice. So is this, well, the solution to everything? Well, no. But at first, I wrote a blog post series about contract testing, about the benefits, about how it works. If you have a look at this link, it's a 6-part blog post series. This is the first one, which links to all the other articles. But so what we've looked at, what I've shown you just now, is the not traditional way, but the consumer-driven way of doing contract testing. But it has some implementation challenges. First of all, it requires teams to write tests. As you see, well, it's when tests are run, only then are the contracts generated. There's still some coupling between the consumer and the provider by means of those states that you've seen, which means that consumer-driven contract testing doesn't always scale well to really large numbers of consumers. Getting provider teams on board can be difficult because it requires a lot of work for them to say, well, what are all the states and the different contracts? And that requires a lot of work, and I don't want to. So it can be difficult to getting these provider teams on board and really showing them the value of consumer-driven contract testing. And it can also be quite hard to getting testers on board because you're really working at the unit test level. It's closely tied to the implementation of the services, which means it can be a little bit harder to get testers on board. And so contract testing is nothing really new, although it has seen quite the surge in interest and popularity over the last year and a half, 2 years maybe. But there's quite a few challenges when you try to implement consumer-driven contract testing. And this is where bidirectional contract testing comes in. So that's a different approach to contract testing. And a big disclaimer here right away is that bidirectional contract testing is supported only by packed flow. That's what I'm going to demonstrate to you now is not something you can do with the open source Docker-based packed broker. This is something that's only supported in packed flow. So this is the flow that we've just seen. So it's the consumer that's in charge, generates the contract, gives that to the provider. The provider shows whether or not it's able to meet the expectations in the contract, and then both can check, well, can I deploy? The bidirectional approach to contract testing is a little bit different. It's no longer either the consumer or the provider that dictates what's going to happen. No, with bidirectional contract testing, they can each of those parties, those two parties, can each give their own version of a contract. And then it's the packed broker that compares those contracts and checks whether or not there are any integration issues, basically. So it's no longer the consumer giving a contract to the provider. It's also not the provider giving a contract to the consumer, because that would be provider-driven contract testing. No, it's both parties giving a contract to the broker, and then it's the broker that checks for compatibility. And then again, if once the packed broker has done that, and again, this is supported only by packed flow, not by the OSS packed broker, then both parties can check, well, is it safe to deploy? And what's super nice, I think, about bidirectional contract testing is that you no longer even need packed to do it. So you still need packed flow, but you don't need necessarily, you can do it using packed, but you don't need to do it using packed. You can leverage a lot of existing technologies and the range, the collection of supported technologies grows by the week almost. But you can derive contracts from existing technology and tests. So I'm going to show you a different example where I no longer call 6. And Paul, I'm going to just trust you on telling me when I'm running out of time, but if not, I'm just going to continue and waffle on. So I switched to a slightly different branch here, which introduces another integration. That is an integration between the order consumer and a payment provider, which is a party we haven't seen until now. But orders, they need to be paid for, so there's an integration between the order consumer, which again takes care of all the data around orders, and the payment provider. As basically, it can, in this case, it queries the payment provider to see, well, are there any known payment? Is this order already paid for? What's the nice thing about bidirectional contracts? And let me also start Postman while we're waiting. What's nice about bidirectional contract testing, again, is that you don't necessarily need to use Pact. If you're using popular, mostly open source tooling to write API tests or API mocks, there are good chances that Pact already supports it. So in this case, the order consumer already has some tests that test whether its current implementation can work with an implementation of the payment service provider. And because it doesn't want to rely on the actual payment service provider, it uses WireMock to do this. So for those of you who don't know, WireMock is an HTTP API mocking library in Java, open source, quite popular. And that's what this team has been using. And the nice thing now is that you can use these existing integration tests or integration kind of tests that use a mocked version of the payment service provider, again, mocked in WireMock, to generate a contract. And the way that works is when I started my WireMock server here, I'm adding the WireMock pack generator. So that's a library. It's basically a listener that you add to WireMock. Again, WireMock will spin up a local HTTP server, which listens to incoming requests. And then if it has a known predefined response for it, it will return that response. If not, it will return a 404. And this pack generator is basically a listener that checks, well, during the running of these tests, which again are some tests using that calls the payment service client, which invokes this base URL to retrieve payment for some kind of order. It's going to use the actual traffic, so the actual request that arrives at the WireMock server and the response that the WireMock server returns, so the mock server returns, to generate the contract, which means it doesn't rely on specifications expressed using the pack library. It's going to use the actual traffic that's being generated when you run the tests to generate the contract. So if I go back to the order consumer now and I run my tests again in this branch, it will run all the tests that it ran before, but it will also now run these tests against this mocked version of the payment service provider. It then generates a contract as well. So this takes a while. It generates a contract between the order consumer and the payment provider, which expectations, or rather, because in the mock in a typical mock, you define how you expect the actual service to behave, but don't want to rely on the actual service, and it uses those expectations that are codified into this mock to generate that contract. So it takes a little while to run the tests again. Almost there. There we go. And now I have... Oh, it hasn't refreshed properly. Come on, reload from disk. There we go. There's also a contract between the consumer and the order consumer and the payment provider. If I now publish that to pack broker again. It publishes this one. That was already okay. This one is now created. There's a new integration that as of yet unverified, because it's the order consumer who uploaded their contract to the payment provider. Now this payment provider is a public API, and public APIs and consumer driven contract testing do not go nicely together. So if you have public APIs, trying to make those provider sites do consumer driven contract testing is going to be virtually impossible, because, well, it's a public API. It's basically the provider saying, well, this is what I do. But what's a nice thing about this public API? They typically have some kind of contract of their own. And one of the shapes that contract can take can be as simple as the open API specification of that service. In this case, my payment provider service. And that probably has, and it's quite likely that that's public, so that you can use that to do your contract testing. Because this too is a form of this open API. It's a form of a contract because it describes the behavior of the payment provider. So it describes, well, these are the paths that I support, the HTTP methods that I support, and these are the HTTP status codes and the shape of the responses that you can expect. So let's quickly look at this flow again. So I've done the left-hand side now. I've used consumer. Again, it uses, instead of using packed to generate the contracts, it used that wire-mocked packed generator, that listener, to listen to what's happening during my tests and generate the contract from that and upload that to the packed broker. But the provider can now also, let me just quickly, I'm going to need to encode that because that's the format that oh no, I don't want to do that. There we go. As of now, there's a bit of an arcane API call that I need to make to upload that actual contract. But what I'm doing is con HTTP put to my broker and say, well, there's this payment provider version 100. This is the contract. It's an open API specification kind of contract, which is a YAML file. And you can upload some additional verification results. As a provider, that's a courtesy thing to do. So, well, this is, for example, this is what I did to prove that my implementation is correct. But the most important thing is, well, it uploads the actual contract. So if I send that, it tells me created, and now the provider has uploaded their version of their version of the contract as well. And what Packflow will now do is compare the consumer contract, which again generated from these YMOC-based tests, and the provider contract, again this open API specification, and see if there are any potential integration issues. And in this case, there's a success. We can view the contracts, the consumer contract, which contained these paths, and the provider contract, which was this open API specification. And it's the packed broker that did the comparison. And again, this is supported only by packed flow, not by the OSS packed broker. So in turn, I see it's almost 6 on my end. So I'm going to wrap up and free the stage for Jonathan. But what's nice about bidirectional contract testing, when you compare it to consumer-driven contract testing, is that it's much easier to get started with, because there's a lot of existing tests and infrastructure and existing specifications and contracts that you can leverage to get started with contract testing. Again, at the goal is the same. It's finding out at any given point in time, can consumers and providers successfully talk to one another. That's still the whole point of contract testing, no matter if it's consumer driven, provider driven, or bidirectional. It's just with bidirectional, it's easier to get started if you already have some existing tests or infrastructure in place. With consumer-driven contract testing, you need packed, you need to write those tests, you need to write the specifications, which works very well if you're starting a greenfield project, for example, or everybody really wants to do it, which is unfortunately not always the case. But bidirectional is just easier to get started with because it's much easier for both parties. So, well, I've already got these tests, this technology, and if Pact supports it, and again, the list of supported tools and technologies it includes, so it can do Postman collections, for example. It can use Postman collections, Cypress tests. I've showed you WireMock. It can do wiremock.net as well. It can use rest assured tests. So for the provider side, where you say, well, I'm testing my provider implementation with rest assured test, it can use, well, what's happening in those tests as a provider side contract. So it typically takes a lot less effort to start with bidirectional contract testing. Yeah, I've got some links basically, and then I'm done. Pact Flow. If you go to the Pact Flow site, you'll be able to find a lot of information in the background about why bidirectional contract testing came to be in the first place. My blog post series also has one post on bidirectional contract testing. And the code's all on GitHub. So if you go to my GitHub page to this repository, you'll find all of the code that I've shown you in this talk. And that is it from me, Paul.
That is terrific, Buzz. Thank you so much. I am looking over here to see if there's any questions, and we didn't get any questions up on this. So this is pretty cool. I learned a lot about this. I really need to get more into API testing, and this Pact Flow. Where is it? Like pactflow.com. We can take a look at that. Is that where we can?
It's pactflow.io.
Pactflow.io. Excellent.
If you go to pactflow.io, you'll find everything, and it's not just it has a whole lot of documentation and other information about it as well. There you go.
All right. Cool. Any last any ways we can contact you? Any ways that you want, anything you want to share with everybody on where we can see more about that?
Well, basically, if this shameless self promotion, this is my site, and you'll find contact form and everything on there on testautomation.com. That's the easiest way to get in touch. Email or maybe LinkedIn. There's a contact form. That's it, really.
Terrific. I did notice something else when you were using IntelliJ from JetBrains. I love their IDE. Anything in IntelliJ that you want to share? Like, I mean, we have a choice. You know, you've got VS Code, you got Eclipse. Nobody uses Eclipse anymore. But
you'd be surprised. You'd be surprised how many people still use Eclipse.
I'm a little jaded. I worked on Eclipse for 2 years, and I went, you know what? I actually love JetBrains. I love their tools. I'm actually working in WebStorm right now in JavaScript. So
what I love about it, it's basically everything is 90% IntelliJ anyway. So like yourself, probably, I work with quite a few different programming languages, and I love the fact that with all of these programs, at least the IDE looks the same.
Yes.
So whether it's as you said, WebStorm or PyCharm for Python or IntelliJ, and for some reason I then still use Visual Studio if I do C# work and not Rider. But don't ask me why.
I won't. Hey, Buzz, thank you so much for joining us. I really appreciate it. I'm going to get Jonathan on here in just a minute. And cheers, and thank you so much.
You are more than welcome. Thank you for having me.
You're welcome. All right, everybody. That was our first hour with Baz out there talking about the contract testing. And we have our next speaker coming up over here, Jonathan Wright. Jonathan actually has a podcast. It's called the QA Lead. I like to give a little a shout out to that because he asked me to come over and speak with him on that. We've been having a ton of fun for at least 2 or 3 years on several different projects out there with the British Computing Society. So and I think I met up with him at the beginning of the pandemic. We had a virtual event where everybody kind of came together and we all kind of had little avatars walking around in 3D. And if you had VR goggles, it was even more intense. So it was just a ton of fun out of that, and even won myself a second pair of VR goggles going to that. So it was fantastic. Anyway, there's Jonathan. Hi.
Hey, how's it going, Paul?
It's going good, and your mic is working. What's that? I'm sorry.
I've missed you.
I miss you too, man. Yeah, we got a little bromance going on over here, all about test automation. It's fantastic.
It is. And the thing is, we got the Mercury men that are both in our background. So we got the Mercury
thing. We do. Yeah. We go back a ways to our. Yep. Well, that one's not worth anything anymore. Yeah. Back in our days when we were working at Mercury, and in fact, I believe I also have I even got a Mercury.
I have that mug. It's awesome because the screw top keeps everything really cool.
Yes, and people keep sending other tools, keep sending me stuff. So I always like to kind of show off other. Everybody, I got my little list of all these tools and companies that send me stuff. So it's always kind of cool. I wish I would have gotten a ton of those. I think I had like 1 million points of support points, and I just cashed in one. I'm like, I should have gotten 10 of those things. Anyway, I'm not going to talk too much more about this. We've got Jonathan right here, and he's going to talk to us a little bit about digital twin testing. Again, another area that I am not entirely familiar with. I'm looking forward to learning a lot more stuff. So, Jonathan, you can unlock the codex and give us some cool information about digital twin testing. Take it away.
Wonderful. I'm just checking that my microphone sounds okay. I just realized that I've got, as you probably can tell from the background, I've got like 6 microphones, like 12 screens. So I'm kind of sat there talking into this microphone, which is sure one that Michael Jackson used, and then realizing that actually it's not that mic because I'm on a different network thing. So hopefully you can hear me okay.
It sounds much better. Yeah, you're okay. 5x5 now.
That's what we needed to do. And of course, we need to catch up, especially with the. I'm sure you heard about the like everybody in the entire world did about open text acquiring Micro Focus, which was HP, which was Mercury, which is a very interesting landscape in the last couple of weeks. So so lots of interesting stuff happening and exciting times to talk about. And I'm probably not going to get as much coding in my session as that. I like you. API testing. I want to say is my friend. And of course, I'm seeing more and more stuff with Pact as kind of a way that people are starting to use it. I actually did have a call the other day with a good friend of mine, Alon, who was the founder of BlazeMeter, and he's also the founder of a company called up9.com. Up and then the number9.com, which does all of the stuff that was demoed there, but uses AI to actually generate it. Very, very sophisticated, very clever platform. And he actually showed me a demo. I think it was in, it wasn't in Eclipse, so you don't need to worry, but it was in Visual Code, VS Code, and it literally, you pointed it to a Swagger or an Open API spec. It would auto-generate the payload and everything they needed. But then as soon as you pointed it to the new version, it would then regenerate everything. So you could kind of get to that point where, if you're reliant on Rest Assured and, Wiremark and stuff like that, and, having to keep on changing things, it accelerates stuff. So anyway, I better share my screen because I'm getting told off by the moderator to just sit and talk to you, which, in all fairness, would be fantastic. But I guess I should show people something. Otherwise, they've come to see the Jonathan show, right? Well, hopefully you can see my screen. And it should say shift right into the metaverse with digital twin testing. So as long as you can, I'm going to start continuing anyway. I think we've got an hour. I don't want to bore anybody, so however long it takes, it takes. I think interestingly, I've just been sat on a call, literally while I was preparing for this, talking to the teams around testing in the metaverse, and I'm going to show you some of that stuff what I've been doing. As kind of my good friend Paul kind of mentioned before, I've been sat in kind of the automation space for 25 years now, or 4 decades, depending on which way you want to look at it. I originally did a TED talk many years ago now, and actually the TED talk covered the mixed reality in the metaverse. It actually had a scene which I'm going to replay in a second for you, where it's going through what the future would look like. And so all the stuff what you see in the background is kind of stuff that I played with over time. They're all kind of really quite kind of complex, very futuristic, and literally the call that I was just on, they were kind of saying to me, it's if Gartner have got the metaverse at the top of the hype curve at the moment, literally launched it 2 or 3 weeks ago, and we're talking, with both Meta and Microsoft at the moment around testing in the metaverse and automation. It feels like it's such a long way away, but in actual fact, like everything in our industry, is that actually, this kind of technology really does. It kind of changes the way that people use and consume technology. So as soon as someone like, I know we got the Apple event tomorrow, but as soon as they launch something like the Apple glasses, which is scheduled for 2024, 2025, the consumer adoption will just explode. And then, of course, like Appium for mobile, there'll be equivalents. And, my good friend, Sean Evans, who's used to be one of the guys with LoadRunner, he's just.
I hate to interrupt you there, Jonathan. Looks like we're having a problem with the camera over there.
Okay. Is it my camera?
On my side, I can see it. Okay, I'm seeing the your PowerPoint being shared over here on my live session. So I'm just checking with our moderator if everything looks better. Because over here I can see the shift right into the metaverse with digital twin testing, and it looked like the camera was okay on my side. So I'm sorry to interrupt you. He says your camera's not working properly. I can see you from the YouTube stream, so I'm going to say let's keep this going because it looks fine from my end. So my apologies for interrupting there.
Oh, not a problem. Like I said, I could just spend for the next hour just talking to you.
We lose all our viewers. We would bore them so bad.
It'd be worth it. I can tell you that for nothing. Anyway,
we'd start talking about Captain America and your little cameo in there, but okay, we'll leave that for another time.
Absolutely. So I am looking at the live feed. It does look like I'm slightly frozen, but I don't know if that is just because we're doing it. But let's keep it going and see if it goes, kind of work goes okay. So anyway, yeah, like I said, I kind of started in the 90s, and you said to me, do you want to promote anything? And even if you see the standard frame of me in the background, you'll see that I've got 4 books on the back wall. And while lockdown happened, I published it was about 3 weeks ago, 3 months ago, the artificial intelligence for software testing, which is on the far end. So I was part of doing that. Now let me just have a quick look because it does look like I am still frozen. So let me just quickly change my camera to something else. Give me a second, and then hopefully it looks fine on mine, but it probably is something to do with technology. The great thing about having 12 screens is good, but then, you know, it's an overhead as well. Yeah, it does look like I've got my cameras frozen. So give me a second. Disable camera, re-enable it. Let it give it a few seconds to come back into its life. Right, full definition. Anyway, hopefully you can still hear me anyway, even if the camera doesn't let me show myself, even though it's coming up as maybe it's a bandwidth problem. I can't imagine it's bandwidth. But anyway, let me swap that to another camera. I do have two cameras. See if this one is any better. Give me a second. I love the technical challenges of doing these events. Okay, so this is another angle. Let's see how long this camera survives for. So yeah, so let me kind of move forwards a little bit and let's get into this the metaverse stuff. So you know, part of it is, you know, like I said, you know, I've spent a lot of time working at companies doing thought leadership. You know, I've got another talk with the Eurostar next week and a few other events which I'll try and add in. But yeah, I kind of wanted to go back and talk a little bit about, you know, I talked about the fact that, you know, VR seems like the future. And, you know, I was in Santa Clara a couple of weeks back, and, you know, again, it was, you know, visiting the original garage, HP garage, where Bill and Dave in the background on the left-hand side first set up their company in 1938 and 39. And then I was in Bletchley Park, which is just a few miles from where I am at the moment. And saw the original works of Alan Turing, right? And you know, part of that is, you know, we talk about AI now in tech, but of course those things have been published and talked about for many more decades, right? So anyway, let me kind of go through, and that was me in next to the HP garage the other day. So let me kind of get into the metaverse, and I'm going to show you testing the metaverse and how that would work. And most of the tech, in actual fact, is quite easy to access from just your normal automation kind of capabilities. So it's not that crazy, because in essence, the Oculus is just a glorified Android device, right? So it in essence still runs a variation off the standard Android kernel. So you can see where things like Appium being extended into doing testing with those headsets is quite easy. Of course, it's slightly different when you're looking at mixed reality, and so what, like I mentioned in the talk that I did, mixed reality is where it overlays into the real world. And so I'd done this kind of, you can probably slightly see in the background, this kind of shopping segment where it's overlaying information into the real world. So what does that actually look like? So this is a kind of the one that I actually demoed, which shows you how it's overlaying all that information. So if you think about the contract testing you've just talked about all those kind of API endpoints, you know, and you may be doing kind of multiple different kind of E2E kind of environments. They're pulling out all that information and overlaying, whether it's weather, whether it's advertising, whether it's, you know, telling you that you shouldn't be walking on the road. All of that information is, you know, is potentially going to be pulled from lots of different endpoints. So it's going to be really interesting to see if, I'm just closing on the, you know, how this is going to change, because you're doing these things like the shopping experience, and that shopping experience is going to potentially be completely unique to you, and you're augmenting this into your daily life. Now, I was in the south of France last week at Capgemini's campus, and I was doing this demo with the HoloLens on top and walking around showing how interacting with things and how we test it. And of course, people like Capgemini have recently announced that their partnerships with Unity, and Unity's in essence is the framework which most of the tools are actually running on. So GameDriver.io, which I mentioned earlier, you know, from my friend, you know, part of it is they're hooking directly into Unity. So anyway, so kind of gives you an idea of what maybe the future is going to look like. What does that look like from a testing perspective? How am I going to test these kind of next generation platforms? So, like I said, I was in the south of France, and I was doing, you know, this demo, which if I press play, you will see. I was just kind of showing how the HoloLens works in the sense of its understanding using the multi-LiDAR cameras, where the floor is, where the walls are, where the depth is, and I'm using gestures using my hands. They also can do eye tracking, so it's looking at my eye using infrared and then understanding that as, in essence, another controller, so I can move the location around. My good friend Toby Marston on the left-hand side, who actually was originally Mercury and HP as well. And part of validating these kind of environments is, there's a number of different ways you can do this. Now, of course, it's an image. You see an image which is live streamed from my headset, so you'll see me walk past my laptop, and that stream of what I'm watching is streaming directly to that, and I can test that because, in essence, it's a two-dimensional image. And if I wanted to just overlay it, and I'm going to show you in a second how we do this with computer vision and Google computer vision, for instance, I can literally say to the tool, or even Google computer vision, show me a dog, and it will highlight the dog on the screen. Now, of course, I then can overlay the actual cursor to tell it to click on that or interact with that. So you can kind of see how do you validate these new types of mixed reality landscape. And you probably see in the corner it is last week, which was the 31st of the 8th or whatever it is. But as you can see, there's also all this additional sensor information. There's sensor information mapping the floor, Toby's donut, which he's eating. You can actually see the different. Well, as it scans and learns the environment, it then understands there's a table there. So if I then wanted to walk over and drop an item onto the table, virtually or not virtually, you can see this kind of collaborative kind of challenge. And so things like Meta and Meta Workspaces is a new way of collaborating with people who are using Teams, plus using VR and MR headsets to immerse themselves into these collaborative spaces to be able to actually work with people in this new world way of working. So, part of it is, I kind of, as you probably kind of expect by the multiple cameras that I've got here as well, is like, I usually have 7 or 8 screens around with me. I kind of, take these around multiple screens when I'm typically working on, because you need quite a lot of kit when it comes to working with, VR. It's obviously needs a lot of GPU. And you probably did see that I actually used the Steam Deck for doing demos, because that's actually got a dedicated GPU in it, and I can actually plug in via the USB-C, and I can actually stream stuff onto that device and then do the testing on that device. But you need to have that kind of kit to be able to actually test. The other thing is AI also has that additional level. Things like computer vision, you need either connectivity to Google's service, or again, you need to use something like OpenCV or equivalent, which again is going to start utilizing your kit, which you're actually having on your machine. So what's the real use cases? And so, I was just talking to the guys about this on the previous call, is, we're seeing things like you're seeing probably on the right-hand side is the Ray-Ban stories, which obviously don't augment anything, but they're starting to introduce this idea of adding cameras to your glasses, a bit like Google glasses. So you can start looking at depth, etc., in kind of a stereo image. You've got the traditional ones. You can see there it's like a photo from 4 years ago. Just using the sensors which are on the lights that are on the actual 6 directional inputs, and it's obviously tracking those. So that way you can, in this kind of lovely avatar world, very similar to the Disney game that just released, you can put yourself in this virtual environment. So, I was the last event that I did. The last event that I did last week was with a guy called Dr. Tarek King, and from Test.ai. And he showed me, this kind of the standard demo. All right, I can drive it and sort the inputs. I can just keep on saying move left, move left, move left, which is not a human activity. But I can easily control any of the directional stuff, because in essence, this controller has just got an input to it. So this kind of technology is really quite simple. But then there's other aspects. Once you've got the ability to control the headset and move it, how do I then validate what's going on? So in this particular demo, I've got a script on the left with Google Computer Vision. I could use some other thing, but I'm just using it for this example. I'm running it with a string saying, look for this value on the screen. And obviously it comes back and it highlights just like it would do on a normal kind of DOM identification tool. Same thing, put another change one, looking for suggest for you, it picks it up. But obviously it's wrapping in the sense of not like Snoop Dogg, but it's wrapping the image around your eyes. So in actual fact, it's not a flat surface, even though it looks like a flat surface. Therefore, normal traditional OCR techniques of just looking for a string don't always work. And the next thing is then, okay, once I'm able to look and identify the items, you probably can see in the bottom corner as it runs, it's found Internet Explorer, but now I'm having to move the directional controller to go left to look, go to be the same level as it, and then go up, and then click on it. And then, of course, it's driving a browser and your normal Selenium kind of thing. In this particular case, we can say to it, look for something on the page. Additionally, as you can see, it's got the eggplant stuff instrumented on the actual device. On the right-hand side is actually all the telemetry information that's coming out, the GPU, what's working, all the information that comes out from your inputs, the camera feed. So you can probably see there, Gareth in the Cambridge R&D labs on Friday. You can take all that information and you can then dump that to a file, and then you can, in essence, as much as I never want to use the word record, replay, you can capture all of the inputs and then just play them back on the device using the auto test function. So, like I said, a lot of this already, exists as kind of open standards. But again, this gives you the ability to drive any of these devices, any of the inputs on this. So whether that be the 6 directional controllers, which are in essence just Bluetooth input devices, whatever it is, you can control in it and power. So this kind of level of capability, why do anybody care about the metaverse, and why do we want to test it? Well, I think we've all, including today, we've all seen this kind of explosion post-pandemic. Of course, when I was talking to Paul a second ago, during lockdown, we did a lot of this running events virtually. And I'm sure we've all got quite Zoom fatigued already. But talking to the guys at Microsoft around kind of their platforms and what they're trying to do, they're obviously releasing Microsoft Mesh, which you see at the top, is where you can then replace yourself with an avatar version of yourself. Now, I'm sure everyone has been on enough calls recently, and hardly anyone turns their camera off. And also, cameras like it had today at a level of complexity and also bandwidth requirement. So this ability to just look at what your facial stuff, and part of the eye tracking technology that they're using at the next generation of Apple glasses, Google glasses, which was announced at the Google.io event, and then of course the Microsoft mixed reality, and of course the Apple glasses, which are again coming 2024-25. And as you can see, back in 2014, I'm embarrassingly wearing the first generation Google glasses. Of course, I had a lot of problems, a lot of privacy concerns. We've kind of been there a few times after. It's kind of this challenge of adoption. So I'm hoping we're going to start seeing a lot more of this kind of, now that we don't have to turn our camera on, people can still see gestures and impact. We're going to start creating more and more of an avatar version of ourselves. And we're massively going to be kind of looking to the future of how we interact with other people. And I'm hoping that I can find Paul on here. I'm sure he is somewhere. But yeah, during lockdown, we ran events where, there's these little 8-bit ones where you can walk around and interact with each other and talk to each other, which is really cool. But, I think we got quite bored of the same kind of format. Part of it is we wanted to be able to interact. And as Paul said, we ran a few of these events, and I'm sure I'm hoping that I can see Paul in there. I'm sure he is there. But yeah, part of it is these platforms, and this is one of the platforms you can see running this conference in VR. So we've got people, on the standard Zoom thing in a 2D kind of landscape, but then we've got people walking around, actually talking and interacting with other people in the room. And it just brought an extra level of depth. Now, of course, people might say, well, it's a bit of a gimmick. But being able, things like Meta's commitment of renaming itself from Facebook, spending 11.4 billion last year on metaverse and spending a further 30 billion over the next couple of months, it'll be a couple of years. Suddenly this is a big market. Gartner obviously putting it on the hype curve, but also the industry is evaluated at somewhere between 300 and 500 billion by 2025. So massive investment from tech companies, of course, people like Facebook. So yeah, actually, I didn't realize there's this video in, but it's Paul Grossman is actually on the bottom list on there. So hopefully I will wander past and see Paul at some point in time. But this kind of environment, collaborating in is great, but also there's a certain level of realism. Your body, will not, doesn't believe it's a real thing unless it's running at the new devices. So Oculus 2, for instance, is running at 4K or 4K per eye at 120 frames per second. The new Oculus Pro get launched this month, twice the price as the consumer device. It's going to have the full see-through into the real world, but just by cameras in color. Yes, here is Paul. He's stood still. I'm sure he'll do something in a second. But actually, in this particular environment, Paul was presenting in VR to people around doing a demo. He's actually doing a live demo whilst actually in VR. So you've got these tech's got to work. If it doesn't work, it's gonna have a real problem with how people collaborate, how people work together in remote locations. And there was, of course, a famous bit of news about the twins that were separated using mixed reality technology from a hospital in the UK to somewhere to these two twins that were attached. Part of it is you can see the use cases that are coming in from both military. Of course, HoloLens is famously known because of the £15 billion worth of DoD contract. They've all just been rolled out into the US Army. So they're getting the information that pretty much allows them to see through walls, get GIS locations of everybody's movement. Suddenly the technology for the next day is next generation is going to be huge. But yeah, so we're seeing this, but then we're also seeing this in these kind of blended things where you've got a mix of an app on the left hand side. And I was in Disney soon to be 3 times. I was there in January. I'm in Anaheim, and then I was back out there in Orlando. So going on the same thing over there, and then I'm back for Star West next month, speaking at Star West. So I'll be back at Anaheim again. 3 times to Disney in 1 year is a bit too much for me. But part of it is what you can see on the left hand side is saying go up to the shuttle, and based on GPX information, it's then saying, okay, now do the next thing in the story. And the next thing in the story, I'm queuing for, in that particular case, Rise of the Resistance. And then you're augmenting that with, the real world and what's happening on the right hand side, which is again a unique experience. Is it's a GPU, so everyone's inputting a device, and the whole hydraulics and everything's moving. But you can kind of see how these mixed multi-reality experiences suddenly get something that's very, very basic to actually, go into shops, locating you to walk to other people or whatever else, makes it, blurs the boundaries between the traditional mobile and the tech. And part of this avatar thing, which, we kind of mentioned about this representation of ourselves, here's a kind of a 3D model of myself. And part of it is me representing myself in that landscape, in the metaverse, in 2 or 3 dimensions is completely different to a standard avatar, or just represent a flat image which people see. So you can start seeing that this kind of technology is there. The scanners that are actually there on everyone's phone. So if you've got an iPhone, and I'm sure the new 14's coming out tomorrow. Part of these, the LiDAR capability here allows you to scan your face and create a 3D model of yourself, and then, send that to your printer. Part of it is this tech exists, people do use it, and people are adding applications for it all the time. And the thing is, I got to guess, joked with Paul at the start, is that, we've been here before. This isn't all new. And, I'm speaking at a conference here in in Australia in I don't know where it was at the time, but we're learning so much from things like the game industry. The game industry has models which are built on physics engines, which we can understand to a certain level of realism. And I'm going to start kind of introducing the concept of not only, applications like gaming driving this, and I've got actually the picture in the photo is every Friday during lockdown I was part of a gamification guild, where we were trying to learn different techniques for engaging people. And part of it is, this isn't new. I did need to update this on my Steam update the other day, but I 16 years being on that platform, and on the right hand side, you can probably see, and this was in the 90s. This is actually a 3D glasses, so it was actually using the scan very similar to for every other frame to allow it a standard 2D screen, obviously a CRT monitor in those days, to actually allow me to actually see something in 3D. So, this technology has gone through many waves, and therefore, mixed reality moving to VR isn't new. This kind of technology has been in there for a long time. All these kind of gamification elements of, competing against other people, getting people to collaborate and, get good scores from doing something, whether it be coding or, collaborating on a farm, right? Part of it is these kind of levels of interaction, which we've supported in the gaming industry, and you can see how old that is on the right hand side. I think you've got Julie Gardner and a few other people helping create a farm. Part of it is you're testing this kind of gaming engine in essence, but in the real world, because you're overlaying all the technology and all the models to be able to validate, well, what is the experience, how smooth it is. If you see on the bottom left-hand side, that is actually a VR game, which was Half-Life. If anyone remembers, Half-Life was the first really mainstream 3D game. They brought something out, and if you go around it, you feel very sick because your body doesn't believe that you're moving around or warping around because you're not walking. Whereas with mixed reality, you can literally just walk around your house as normal, don't bump into things, and actually interact with a blurred technology in the real world. So, we've seen this for a long time. We've seen kind of entire cities being able to be built, and again, these things aren't new. These date back to the noughties and even some of the 90s. But then we've got all these additional kind of things on top of it. So one of my friends, a guy called Magic Zaleski, he's, I always see him as the automation guy that I wish I was, apart from being Paul. I could definitely be Paul as well. But, last time I spoke to him, I said, what are you doing? He said, oh, well, I'm doing NFTs and crypto wallets and testing crypto wallets. And of course, we all, went through a phase of talking about blockchain and, how would we test blockchain? It's that same kind of thing now. It's like you talk about NFTs, how do you test NFTs? Or, we know about, for the metaverse, you can buy, I think Nike made hundreds of millions selling NFTs with trainers. So you could buy a pair of Nike Jordans, as per behind me, and then actually get a digital version of those shoes. So then if you literally turn your augmented reality camera on, you could see you wearing these virtual shoes, which seems incredibly stupid. But actually, because it's a item that's unique and you own, then you can actually put that into whatever world you are. So if you're playing Fortnite or you're actually in the metaverse, you will own that. And so people are starting to buy up estates in the metaverse and actually buying cars, equipment. And if you've ever watched Ready Player One, you can start seeing that, these transactions for NFTs, which could be millions of pounds people are spending, are really quite valuable. Even some people are even saying more expensive than the actual original item. So things like the Mona Lisa, owning the digital rights for that means people have to pay you if they ever show it on the screen. But, once you own it, you own it digitally. So really interesting. The NBA do it, doing kind of, anyone who ever scores a basket, you can have that NFT. And then what they have behind that is something called an oracle, not like Oracle as a database, but that oracle informs that NFT about its status. So it'll have all the information about who shot it, how many shots he's ever done, what the time was, what his entire, track record was. But moving into the VR experiences where Aston Martin actually sold one car, which was I think 3 billion, with an NFT version of that car, and it was only one that they were ever going to make, one of the physical car and one of the digital car. Being able to, and if you've ever watched, read the book Snow Crash, which is when the metaverse came out, the term metaverse came out, he has a samurai sword, which he inherited from his father digitally, as in the item doesn't really exist. But, you can start seeing this blurring of the boundaries of, driving a car like I did. I have a Mini parked outside of me at the moment, and then having the virtual version of that same car that you own. It's and people like I spoke to a couple of the German car manufacturers who are actually having NFTs in the cars. So you unlock an NFT to say you've done 100 successful car parks without crashing into anyone. Now you get the auto park feature, enabled on your car. We know BMW are doing, heated seats as a service. You could win those by or even own it from your last car. And then when you buy the new car, they'll turn around and say, okay, well, you own the NFT, or you'll sell that NFT, that unlock mode, which you got because you drove a Tesla very, very well for 5 years. You could sell that on, and it would be an extra value item because only a handful of people have Uber level of their capabilities. So, this kind of tech, as much as it sounds crazy and it sounds very futury, I was at CES you can see on the right hand side back in January, and everything that they had was things like this. I think if it doesn't happen in South Park, it's probably not a real thing. But they were all talking about NFTs. They're all talking about creating NFT marketplaces. They're talking about blurring that kind of, well, when should I be giving an NFT away? People like Spider-Man were showing. Giving away a scene of the movie for people who bought the tickets to go and see the movie. So NFTs, the metaverse, of course, all sound like glorified, topics. But in actual fact, this stuff, is real, but it's also, incredibly popular because people need to be able to test these environments. And we've got a picture there of the self-driving bus in Singapore when I was in Singapore. That's, again, 2017, so 5 years ago. And our launch at Keysight, which you can kind of see, there's me with my red jacket on all the time. So we've created, just underneath this guy's hand, is that we've created a radar emulator. So it actually, allows people to test Car2X by emulating up to 500 devices, but 500 items, people walking across, birds flying out in front of the cars, whatever it is, they can do it, and we test it, right? Keysight, for those people who are not familiar with, Keysight is actually the original Hewlett and Packard, what they were building in the garage. That instrumentation arm of HP got spun off into to what is now Keysight Technologies, in the same way Broadcom was a spin-off of also HP. So that's where the HP kind of references come in. But again, the scene emulators, they're this kind of technology to test autonomous cars. And there's an autonomous robot there, which I was sat next to in Santa Clara, one of the malls, right, which notoriously fell into the river because someone walked past it, was going to directly collide, and the robot decided, oh, well, I'm going to have to throw myself off my LiDAR kind of track to avoid not hitting the person, but then ended up in a fountain. So part of it is this tech is there, people are using it, there's business applications. We all know when we look at things like, Car2X or Tesla's autopilot, it's got all this information. But the problem with autonomous is exactly what it says. It is using the camera feed and the computer vision to then say someone's walking out in front of you, and then stopping and applying the brakes and creating a full image off the road, and then having to do millions of simulations to be able to test these kind of environments. Now with Car2X and infrastructure to X, the idea is, you're stood at the traffic lights. You can't physically drive through them until it goes green, because the infrastructure, i.e. the traffic lights, talking to your car and saying no. And so people like Aldi are already using this technology. The radar emulator, which you see on the right-hand side, which is popping up at the moment, like some futuristic Star Trek thing, you can see it's just a whole stack of sensors underneath it, which, a bit like the Matrix, can emulate what those cars or movement is on the screen. And that allows you to start testing things earlier and then not reliant on the actual real world. So the people in the middle just stood outside of Canary Wharf in this particular instance is Stuart Moncrief, who has got myloadtest.com, and then Magic, who I was just mentioning, Magic Zaleski, who is now doing NFT testing. So this tech, and of course with COVID and everything else, testing in the wild is very challenging. So part of it is, like I said, there's so many applications to this, but there's also so many stories of things that go wrong when it ends up rolling out this technology into the real world. So I think the most recent one is probably going to be HBO Max. HBO Max, everyone's excited. It's Game of Thrones and House of Dragon. It launches, it goes down, everyone starts reposting, including myself, down detector to say, well, HBO Max has gone down. Of course it has. But HBO don't have a cloud, right? Apple don't have a cloud. So who went down? Was it AWS? Was it Azure? Was it Google Cloud? We're so reliant on other people's technology that when we start doing chaos engineering, I know Paul mentioned earlier about the QAlead.com podcast that I did. They had a really good session with a guy called Colton, who owns a company called Gremlin, and they do chaos engineering testing and allow you to do, and I know AWS 2 weeks ago now brought on a new service, which is a fault injector service, which pretty much just kills your Kafka or injects loads of messages into it or does stuff that breaks your infrastructure. So you can test how resilient and robust it is, how it's able to resume back. And I joke, when we talked about augmented reality, and it all seems quite primitive in the sense of, oh well, yes, I can go and play a game like Jurassic World and interact with flicking things. And I stood up, I think it's on the next slide or the slide after, I stood up last time I was at Star West, and I kind of said, look, here's the model of testing Pokemon Go, and every single permutation of Pokemon Go, we can emulate the GPX information. I can give the phone feed that it thinks it's walking around a different area, and I can classic gestures to go and catch the Pokemon. So suddenly I never had to leave my house, but I could catch all of the Pokemon. Part of it is someone had to test it, which we did. But these scenarios, especially in the wild, are a lot more complex and a lot more difficult. But they're also at a different scale that we've ever seen before, right? Part of things like them doing, live events within Fortnite, 10 million people all trying to get onto a platform which wasn't really designed to have Snoop Dogg or whoever else speaking. If anyone's watched Mystic Quest on Apple, this joke around, getting so many people, if your servers go down, then it's a massive letdown for all your customers. And it's also you've got to scale at some levels that you're never going to be able to scale at again. So I mentioned testing Pokemon Go and at Star West, and so you can see over here we've got the camera and we've got the actual flow, and it's in the books that I have behind me. It's kind of, okay, how do I fool the sensors? And this was the same conversation we were just having. I was having while the first speaker was on, with Microsoft is, well, we need to be able to give the feeds for the cameras, for the LiDAR cameras. We need to be able to give the sensor information. We're using Connect to do body tracking. We're using custom Raspberry Pis to do eye tracking, where we're creating virtual eyes that then the infrared can follow. You have to be able to emulate all of the sensor inputs and test all of those, so you can then enable automation, end-to-end automation of it, thinking it is millions of people walking around a battlefield, or millions of people collaborating on a project, or even someone conducting surgery, right? And of course they're all very time sensitive and also of lag. And I did this.
Today's talk featuring Jocelyn White as an API tester in the cloud.
So what is an API?
The abbreviation applications.
Alexa, tell Hive to turn on to 21 degrees.
Your heating is now set to 21 degrees.
And the irony of this one was obviously you can see the lag of it going around, but I actually did this live on stage with an Alexa tap, and Alexa, surprise, surprise, started talking to me as I did that at the same time, which I'm sure you did find it on Wikipedia. But part of it is that device latency, and that was the exact same question as well we were talking about. Is if I push a notification to your Apple or Google glasses, how long between me sending it to you getting it in the same way Tesla, you click your phone and it opens the car. What is that latency? What's that round trip look like? What does that experience look like? If something's live or semi-live, just adding in all those times can really make a massive difference. And, there's other things that add into it. We talked about all the sensor information, which you've got, where you can do, maybe Peloton or, your Apple Watch talking to Apple TV for your fitness, right? And also things like geolocations, right? So what you probably see or don't see here is my Greyhound, which was Pongo. And I had a geo fence that said to me, if he gets out of a certain distance, then send me a notification that he's got through the fence or something. The problem is because he topped out at 30 kilometers an hour, he can cover a large distance in that period of time. So yeah, and the same thing goes for devices like scooters, right? I was in San Francisco a couple of weeks back, and I got you order an autonomous car which will come and pick you up. So it comes and picks you up. There's no driver in there. You sit in it, you put your hands on the steering wheel, and then it drives you to your other location. The same thing with the scooters. And I said to them, well, what happens if you'd had a drink beforehand? Obviously, you can't order an Uber then, or you can't get on a scooter. And people have been on scooters in anywhere else in Europe or the US. It'll limit in certain areas. It'll stop in built-up areas because it knows the geolocation. Testing GPX and stuff is very easy, but again, these are all real-world conditions that could lead into something kind of having a bit of a problem. And I obviously fly way too much, but you can see here Red Boot. And I actually was there with a pen tester guy who purposely tried to do some real testing in production. It's probably not good on a plane if you're in the sky, but we see these problems going on in so many ways. And actually, this is again 4 years ago, and you could go to a Chatsworth House, which is where Sense and Sensibility was filmed. And you could walk around the building, or you could just wear a VR headset, or in that case, it was the original Oculus Go thing. But device testing, these kind of devices of the future, incredibly complex. I mentioned digital twins and kind of what is this kind of future landscape looking like? This is a digital twin of a system that we built, which, in all fairness, I should have included the demo. I did the demo at Swiss testing days a few months ago, where I actually showed them, if you go to keysight.com, you can, and then open up your debugging information, you'll see a little file which is called stream. And partly what that does is it allows me to take what's happening on our website and then generate an entire model of the same user behavior in a digital twin. And so part of that kind of capability, one of the reasons I was down speaking with the CTO of Sogeti and we were talking, I said, oh, well, yeah, can you create, a digital twin from things like log analytics? Of course you can, right? Can you take that open telemetry or open tracing and take that information and create a digital twin? Absolutely. And part of what we're doing at the moment is we're working on using digital twins to actually be able to create anything. So we have a project at the moment which I'm running with my team called we're naming it the Flux Capacitor. And within the Flux Capacitor, I can capture anything: API, UI, traffic, whatever it is. And we acquired a company recently called Scalable Networks, which takes a PCAP file and creates an entire digital twin of a network from it. We do the same thing from the demo. What happened earlier for APIs is you interact those, and this is the way up9.com works, is it intercepts the traffic, creates the model based on, in essence, a knowledge graph of that relationship and also the relationship of the source. So, we're starting to use these ones, and I've actually got, next week I'm presenting to Diego for the new Forester Wave. And, the last time I showed him this, I kind of said, look, you could run all your automation in, UFT, for instance, and you know, Tricentis and Soap UI and all these brilliant tools, and then I can literally create a digital twin of them, and I can generate agnostically. It could be in Selenium, it could be in our case, Eggplant, it could be in whatever you want. It could be in Rest Assured. It doesn't really matter. But I can regenerate the entire digital twin and all the testing artifacts out of it. So therefore, you know, you've got that dependency model of, you know, if you're doing contract testing across a number of different API estates, which are all different versions, and you've got that kind of chain API structure, you can literally reproduce that. Plus, you know, from a TDM perspective, you know, create the necessary states and synthetic data. So, you know, digital twins really do bring this kind of capability to allow it. And then the next generation stuff, which again we have at the moment, you know, where it will automatically generate this for you. So you can use things like spiders, and it'll transpose an entire, you know, website or a mobile app or even a thick client application. It will go off and auto discover itself, which unfortunately is badly named as AI Turing bots. But anyway, minus that, you know, this technology already exists today, and you know, and we're leveraging it for large estates of incredibly complex things. I say complex things in the sense that the space shuttle, what was launched, is getting launched this week. We actually tested not only the NASA cockpits and stuff, which I know is Paul's SpaceX demo is phenomenal, but they use Eggplant to test the shuttle. They use it to test the rover inside it. All of that equipment, you know, whether it's a fighter jet, you know, we test that where they're looking through the cockpit, which, you know, Tom Cruise didn't have in the new Top Gun, but you can actually see through the bottom of the cockpit because the augmented glasses are overlaying where the cameras are coming off the actual thing. So we test all of that kind of technology because we're kind of in this landscape. Anyway, 5 minutes left, and you know, I'm kind of muttering on now, so I'm going to kind of, with that in mind, and kind of talking about testing and testing behind the bit in the metaverse. And I'm going to link that bit.ly link, which you see at the moment, which is to Tarek's book, actually, which is really good if you wanted to learn some fundamentals about AI-driven testing and so much more. So anyway, with that said, I'm going to stop sharing my screen, and you know, I think we've got 5 minutes left for any kind of Q&A. Hey, Paul.
Hey, Jonathan. All right. First of all, thank you for bringing up that video of me in the digital world walking around doing that presentation. I think that was one of the coolest things that I've ever done in my life, and it was cool seeing me again, seeing that thing. I just did that whole idea and concept is just amazing. I wanted to ask you: is there any are there any big wins that you get out of testing? Because this seems like a whole new world that we're just getting into. Obviously, any big wins that you've come across on this that you can share?
Yeah, so, you know, I think we're changing the way we test, right? You know, we've been talking about this for ages. You know, it's kind of, there's been this kind of, I'm not saying it's not changed much, but the 4 decades we've spanned, right, is, you know, if you think about Mercury, you think about Windrunner, and you think about Xrunner, right? Fantastic tools, enterprise grade tools that have their own DSL, you know, in that case TSL, and you've got the CD thing in there. I remember we saying that. I found mine in the. I'm going to bring it out and send you a picture. Found them all shrink wrapped windows in the boxes, and we should raffle them off at the next event or something. But you know, that had some great capabilities like analog mode, right? Where it was like XY coordinations. No one ever would use that analog mode. Now we're in the metaverse where everything is an input. And yes, was now reliant on some of that wave of technology where you saw in the demo is like it sees something with computer vision. It then knows it's currently located at X and it needs to move the controller all the way up and down and then click it. You might say, well, why can't we use Windrunner? And we probably could, right? It's kind of the viewpoint of that. The principles and practices that we're using are still the same. Just the testing now is you're testing an autonomous car, or you're testing the metaverse. You know, things are really challenging. And as you know, doing a lot of the NLP stuff, part of it is we need to simplify it for everybody. And kind of this is where I think, we're trying to get to at the moment, is a lot around open testing. It's all around how do we standardize that? So it doesn't matter, it's like the stuff I was doing with Jason and Tarek, with test.ai and the test.ai SDK, which I'd recommend anyone to go off and download. Part of it is it's all open source. It's an extension on top of Selenium that allows you to leverage this kind of battle hardened computer vision to, like what UFT is doing, to kind of allow you to kind of train against images to say, well, I no longer need to record anything. I can just literally say to it, click on this, go and do that, find me a tree, select the tree. It makes logical sense, but everything's sequential. And this was the big challenge, which I think is the change now, is by you writing a script, you are dictating a flow. And I think, that's great, but that's the bit which we need to change. It's the digital twins allow us to create these models of a physical representation, whether it be a piece of equipment like a mouse, generating a model of that is very easy. Or maybe that Atari behind you.
I want a digital twin of this nice little steampunk. That's what I
mean. Exactly. And this is the whole thing, is once you've got that model, right, you can then overlay that. You can create a digital version of that as an asset, which is an NFT, but you can try all the different permutations against it. It's like, how do I test that headset to make sure if people wear it, it works, right? And I think that's what we're getting into, is the blurring of the boundaries between testing and the real world. And part of that is it's not just one solution, right? It is an approach. People like yourself who are highly skilled in automation have learned, and actually it's more about the approach, the methodology, than it is the tool. If everything is a nail, then everything is a hammer. And that was the old windrunner way. It's like, the reason why mercury existed was, where selenium exists, is it was the cure for mercury poisoning, right? We all know that story. Yeah. But I joke the same thing now, is that, what's the solution for selenium poisoning? Well, it's carbon, right? But we're not trying to replace selenium, because selenium is a standard. We're trying to say that selenium's not going to fix everything. How do we, encourage people like Sean to do GameDriver.io to create a driver for gaming environments, a driver for VR, a driver for Appium being the driver for mobile? How do we work on these universal standards that allow everybody to evolve their automation tools to add the value add, like Test Rigger, right? Brilliant product, NLP based, incredibly powerful. That allows people to accelerate and not have to go through all the pain of going through and, learning languages. And don't get me wrong, there's nothing wrong with learning a language, and I would highly recommend doing it. But part of it is, I think we're getting to that point now of maturity that we should be able to do the majority using AI-based assisted tooling to take us 90%, and then use the brain in our heads to take us over that last 10%. And I unfortunately feeling quite crap today, because I spent last night drinking 4 bottles of wine with Paul Gerard. But Paul spoke at Eurostar about exactly this. How do we create every tester into have a superpower, right? They take what we saw in the first session today, with APIs. Part of it is you're testing an application, and your developer, your tester over, your SDED, whatever you want to call him for a second, over there is writing some API stuff. And you're doing some exploratory testing, and suddenly it turns around to you and says, he's spotted something at the API level that could be a problem. Can you go in and validate it, and give you a guidance that if you log in with this user and then change their name from Paul Grossman to the Dark Art Wizard, then go back into an invoice that you already previously, sent out, it'll still be Paul Grossman, right? But it should, based on the new version of the Swagger spec, is it should update everything, because it's calling to get the latest information, because Paul wants to be seen as the Dark Art Lord. And I can give you a bit of I know we've only got 1 minute left. I can give you a bit of a spoiler that actually this year I'm changing my middle name to AI. And I'm doing it for no reason, but just because it's hilariously funny. But also I know every system that I go into now, I'll have to put, whenever it says middle name, I have to put AI. And And so, part of it is I could have changed it to drop all tables with and literally cause some sequence. I kind of thought that was a bit harsh. So I'm being a bit more responsible with my thing. But I think this is the whole thing. We, as much as we're eccentric and slightly crazy, this is what we've got to do. Is we've got to drive the industry to change things and work together, right? It's, I'm going to call it one tool for a second, or one automate. Everyone's got to get to help the automation landscape mature. Don't build your own frameworks, guys. Let's come together and actually allow us all to leverage all of these great powers and give us those superhero stuff. And we can then just work on which cape are we going to wear, what hat should we be putting on, and how cool should we look as an avatar while we're collaborating with the people on test automation awesomeness.
Sounds great. You said you have a book. In the last few seconds, we can give a plug to that.
Yeah, and you wouldn't see me make me short, but I have a new book up here as my AI camera tracks me. Artificial intelligence in software testing with Rex Black, and everyone knows Rex. He was one of the original ISTQB contributors. Great book. I highly recommend it. We're actually, keysite.com is actually, or Eggplant Software, if you go to Eggplant Software, giving the entire book for free. So I'll make sure we share that link with the audience as well.
I always get books, so you can see them all over here. Someday this is going to break my desk, but I like my hardback books. They're everywhere over here. So
I'm going to say your address again, and I'll send you some signed copies of.
Absolutely,
of them, and,
I would love that. Add that to I've got one by Linda Hayes, the automation frame handbook from 20 years ago. So I'd love to add to that collection. Jonathan, I just want to say thank you.
Give them to the audience as well. But thank you so much for hosting. You're a superstar.
Thank you so much, Jonathan. It's been a pleasure speaking with you. And I guess we're going to wrap up this session of the Zappletech Automation Meetup. I might be back next month. We're looking for another speaker on there. So if anyone wants to get up here and show off some cool stuff like Jonathan did over here, reach out to me. I'm on LinkedIn. Find me. Find the Dark Arts Wizard. And with that, I'm going to go wrap it up here. Again, thanks, Jonathan. And thanks to Boz as well. And this is our wrap up for the September 2022. Thanks a lot. Have yourself a great day.